Alright, let's see how we can discharge the two sequence related to guard strengthening of the refinements. Okay, this is anatomy of the sequence for the first events ML out, and this is the solution to the exercise I gave to you. If you didn't really get a chance to do it, I would suggest still pause the video and don't look at the solution. Really try to make sure you can really formulate it yourself. I think that will be very basic but fundamental exercise for you to do, right? So our goal right now is to see if we can discharge this sequence. Is it provable? And right now, I would suggest you pause the video and look back to the two sets of example inference rules that we spoke about. They should be sufficient for you to really discharge, or at least to know whether you will get stuck in the, proving the sequence, to see which way it is. All right, you can now pause the video and find out the relevant sequence to prove one way or the other. Alrighty, hopefully you got a chance to really think about how to prove this sequence, and at least I can tell you that this sequence over here is provable. Alright, you can actually discharge it. And if you really didn't really get enough time to really try to prove it, I would like to offer a second chance for you, right? Because I think it's really important for you to try to prove the sequence. Otherwise, you're gonna prove it maybe during the test, which is not that pleasant. Let's now move on to the iPad page over here, right? So this is the guard strengthening proof obligation for ML out. And that's a sequence to start with. And I can tell you that it will be sufficient to actually prove this sequence over here using only 1, 2, and 3. Only 3 inference rules, which we already covered earlier. You can now pause the video again if you want to try again. Alrighty, assuming that you really try, and let's now talk about how to prove this, okay? And I would say almost always, if you got so many hypotheses in the context over here, it might just distract our attention. We just want to keep only those hypotheses that are relevant to our proof. Of course, the biggest question is, exactly which hypothesis should we drop? Exactly which should we actually keep? I cannot really give you a general principle. All I can say is the guiding principle would be you want to look at, maybe focus more on the goal. We actually want to prove about n less than d. So we want to see which hypothesis might be relevant to proving the truthfulness for n less than d. That will be the guiding principle, right? Let me just write this down. When applying the monotonicity inference rule, guide yourself by the goal to see which hypotheses are relevant. That's a very general guiding principle, but hopefully that will help a bit, at least, to drop or keep, right? It's a very important guiding principle over here. When you apply for the monotonicity inference rule, you want to guide yourself by the goal to see which hypothesis to drop. All right. And when I look at the rule, when I look at the goal over here, n less than d. All right. Well, to be honest, I know the solution already, but I will try to give you as much insight as possible. If you look at n less than d, and if you look at these equations over here, because other things, these are just the typing constraint. And these are simply some property about the constant or the abstract variables. But now we want to focus more on the something that to see how we can use the concrete guards or concrete constraint to really eventually to entail this abstract guard. So we may just want to focus more on this part of the hypothesis over here, right? That's the first thing I would like to start with. Think about this. You can see a plus b plus c equals n, and we know that c is equal to 0. So that means, okay, let me do better. A plus b plus c equals n, and we know that c is equal to 0, meaning that we can cancel this out for now. And then you can see that a plus b equals n, and we got a plus b less than d. By the equality rule, we can actually substitute a plus b just by n. In that case, we got n less than d. And we got exactly the same hypothesis and also goal in the sequence. So that's how we prove it, right? That's how I see it, right? Of course, the insight will definitely just vary from case to case. And proving is a creative process. That's all I can say up to now, right? Anyway, we'll learn from different examples. We've definitely got many proofs to come before we have to say goodbye for this course. Alrighty, let's now, okay, knowing this, so let me just highlight the one we want to really focus on. We want to use this one over here. We want to use this one over here. And also we want to use this one over here. So these are the three I want to keep. Other things, other hypotheses will be dropped because they are not relevant to the goal. So what I will do is I'm going to say monotonicity over here. And you know what? Let me just use a different blue, which I prefer personally. Right? So this will be the monotonicity rule. And we're going to rewrite it by reducing the hypothesis. So I'm going to write A plus B plus C equals N. Also A plus B less than D. And also C equals 0, turnstile, and less than D. Right? So that will be the new sequence over here. So what will be the next? Well, remember the insight I gave to you in the very beginning. Eventually, we want to replace maybe this A plus B over here by N. But before we can do that, we should really somehow show that A plus B plus C over here is indeed only A plus B, given that C is equal to 0. So we should really replace this C over here by 0 first, right? So we're going to need an equality rule. So that will be from left to right, because C equals 0, we want to replace every occurrence of C on the left by 0 on the right. So we're going from left to right. So we are using LR rather than RL, right? That's very important to see as well. So let me just use left, green for left, and also maybe pink for right. So that's kind of consistent with how I explained the equality rule earlier. You can definitely refer to it from last week. Right, so let's find out the instances for C. You can see we got C over here. Right, that's the only other instance we have to replace. But by the way, whenever you apply the equality rule, you have to replace every occurrence of the left-hand side in the hypothesis and also in the goal by the right-hand side. Right, that's what the rules is saying. Right, and if you want to see the detailed walkthrough for the rule, you can refer to the earlier lecture. Okay, let's now do the replacement. And if I do the replacement over here, so I'm going to apply EQ from left to right. Every occurrence of C is going to be replaced by 0 on the right hand side. So what I would get is I'm going to get A plus B plus 0 is equal to N, right? And also A plus B less than D. And this is no longer useful because I already have done the replacement. Here, if you want to show every step, you should really say after this particular sequence, I should really apply again the monotonicity rule to really drop this. That's what you should do. But let's now apply both rules at the same time, right? That's what I show in the slide as well. In the test or in the exam, if I have the requirements that you have to show every step without combining two inference rule applications at one go, in that case you cannot do it, right? Why don't I do it just for one time? How you can do just rule by rule without combining steps? Okay, why don't we do that just for one time? So that'll be C is equal to 0, turnstile, and less than D, right? But I might just need to make this slightly smaller, otherwise I wouldn't get enough space. We'll see. If we don't get enough space, we'll make everything smaller. All right, that'll be the one. Okay. And now we don't need this anymore, right? We're going to drop it. So what we'll do is we're going to, let me just highlight it. So this will be the one to drop, right? In that case, we're going to apply the monotonicity again. And what we got left would be A plus B plus 0 equals N. And also A plus B less than D, turnstile, and less than D. And in the slides, when I show you the proof, and also in the notes, what I show was I actually show these two steps to be combined. I simply say EQ LR, comma, monotonicity. So depends on the requirements in the assessment. But I would say you should really know both. If I ask you to really split the steps without combining them, in that case, you should know how to do them as well. But in the later proof, I might just combine it just for briefness for the notes. All right. So what else should we do? So what we got is we got a plus b plus 0 equals n. And in this case, according to our very basic arithmetic, we know that anything plus 0 is really the same as just anything over there, right? It's a very basic arithmetic rule. So we will allow you to really, well, of course, you cannot really say everything that you don't know how to prove, just classify that as a basic arithmetic. But I would say for this one, it's quite obvious. We can simply simplify it. How do we simplify that? So by the very basic arithmetic rule, I would say ARI for arithmetic, right? Basic one, which does not require any further proof. And this will be this part over here, a plus b plus 0 equals n, would be equivalent to a plus b equals n, right? And also the rest stay the same. A plus b less than d, turnstile, and less than d. Of course, I just need more space. Give me a moment. I can make it happen. Let me make some room. We got very close. Okay, so let me just try to make everything just smaller. We still need a few more steps. Okay, I think even smaller. I think that's good. Okay. So now what should we do? We're getting very close. You can see we got a plus b equals n, and we got a plus b over here. So we might just need one more application of the equality rule, from left to right or from right to left. What we really want to replace is to replace the a plus b over here by n. N appears on the right hand side. So we really want to do is replace every occurrence of the left hand side by the right hand side. So we're still going from left to right so far, right? But sometimes we may have to go from right to left. It depends. Right, let's now go on to actually talk about it. So this time I'm going to combine these two rules in one single step, right? Just to save space. But at least you know the both ways, either to combine or not to combine. So I'm just going to say I'm going to say EQ LR followed by monotonicity. But let me show you the EQRR first. So this is the left hand side over here, and this is just another occurrence. These are the only two occurrences. I want to replace it by the right hand side, which is n. And I'm going to do the substitution over here. So that's going to be a plus b becomes n less than d. And I'm also going to drop it by using monotonicity, right? I'm going to do two steps at a time. So what I will get is simply n less than d, turnstile n less than d, right? That's what I will get. Right, again, we are combining two steps over here, right? The EQLR would be replacing every occurrence of a plus b by n. After that, I still got two predicates in the hypothesis. So I'm going to drop this one here by using monotonicity, right? And so after this, are we done? Basically done. But in order to prove this sequence over here, we want to argue that we don't need any further justification to prove it because the hypothesis rule over here, right? You can see hypothesis actually appear on both sides. In that case, we can simply just use the hypothesis. That'll be the terminating rule to use. Hypothesis, and we are done. Right? It's now proved. So I'm going to put a check mark. Check. Right? So that'll be the complete proof process for the first sequence related to guard strengthening. All right? And let's now move on to proving the second sequence.